We are going to do problem 2 of section 1.
We have a bag of 80 chocolates, 30 are almond, 27 milk, 23 of cookies and cream. Letter A. Probability of both chocolates you picked are cookies and cream. In this problem, you will multiply 23 over 80 times 23 over 80, and you will get 0.0826. Letter B. Probability of at least one is cookies and cream. You will multiply 23 over 80 times 22 over 79 because we already took one chocolate of the bag. And the answer will be 0.080. Letter C. The random variable x, number of chocolates, cookies and cream, results on a binomial distribution. Yes, because you can either get cookies and cream or almond milk.
You can get either cookies and cream or almond and milk. Therefore, either you succeed getting cookies and cream or getting the other type of chocolate.
Letter D. If it is not a binomial distribution, rewrite the experiment so that it will be one. In a bag of 80 chocolates, 23 of cookies and cream, and the rest are not.
So what's the probability of getting a chocolate that's cookies and cream? That would result in a binomial distribution because there's only two possibilities of succeeding getting a cookies and cream or of not. I'll explain problem number 8 from section 2. The problem we're given, they give us a probability distribution table, and they're asking us to find the value of k and update the values of the table, to find the expected value, and to find the variance. So first of all, we need to find the value of k. We know that in a probability distribution table, the sum of all of these will be equal to 1. So we will say 2k, this will turn it into a decimal, so this will be equal to 0.14, and this will be equal to 0.11. We need to leave the k alone to know what this stands for. So we will have 5k plus 0.14 plus 0.11, which is equal to 0.25 equals 1. We'll take this to the other side as a negative, and we'll say 1 minus 0.25, which will be equal to 0.75, and then we'll pass the 5 dividing, so it would be 0.75 divided by 5. So finally, our k will be equal to 0.15. That's our first answer. We've just found the value of k. Then we need to update the values on the table. Therefore, we already know that for 1 it's 0.14, for 3 it's 0.11, and now we need to substitute the k with this decimal. So we'll say 2 times 0.15, which is equal to 0.3, and then we will say 3 times 0.15, which is equal to 0.45. Just to make sure that this answer is correct, we will add all of these to make sure it gives us 1. 0.3 plus 0.14 plus 0.11 plus 0.45 equals 1. Therefore, our answer is correct. Then, the second step is to find the expected value. We know that the formula to find the expected value is the addition of the probability of x times x. So we already have our x values, we have the probability of the x values. We need to multiply these by these and then add it. So we'll say negative 1 times 0.3 gives us negative 0.3. 0.14 times 1, 0.14. 0.11 times 3, it's 0.33. And 0.45 times 5 equals 2.25. So to find the expected value, as mentioned before, we will add px, it's the addition of the probability of x times x. We already did the multiplication, we will add all of these numbers. Negative 0.3 plus 0.14 plus 0.33 plus 2.25. That gives us 2.42. So that's our expected value. Then they're asking us to find the variance. We know that the formula to find the variance is the sum of x minus your u, the u is the same as the expected value, squared times px times the probability of x. We already have this value here, which is the probability of x. We just need to find the x minus the expected value squared. This is negative 3.42, negative 1.42, 0.58, and 2.58. To do this, we just subtracted the x value minus this 2.42. Afterwards, we would square all of these numbers. And finally, we will multiply these by the probability of x, which we have over here. So just to set the first example, it'd be 11.69 times your px, 0.3, which will give you 3.5. And we will do that for all of the numbers. 2.01 times 0.14, 0.33 times 0.11, and 6.65 times 0.45. And to find the variance, we will add all of this. 3.5 plus 0.28 plus 0.03 plus 2.99. And our answer is 6.8. We just learned how to find a value in a probability distribution table, how to substitute the values in the table, how to find the expected value, and how to find the variance.